we want to introduce the company. Stratio is a big data company with 7 employees. The headquarters are here in San Francisco. And we are going to explain the project that we made during last year for Telefonica. Telefonica is a very big company. It's a telecom operator. It is right now one of the 5 biggest telecom companies in the world. He's all around the world. These are some of the brands: Vivo is in Brazil, O2 is in England, Germany, and Telefonica and Movistar are all around the world. So, what is the project that we built for them? It was something for cybersecurity, and the question here is, what is cybersecurity? So we are going to try to explain it as easy as we can, and also pretty fast. So please, Antonio, if you can explain.
Okay, so here, how many people know what is the cybersecurity? 1, 2, 3 persons. Okay, it's very common this situation. Now we know who is Telefonica, but everybody don't know what is the cybersecurity. When I started to collaborate with Telefonica in this project, I didn't know anything about the cybersecurity. And the people of Telefonica began to explain me who is the cybersecurity, explaining with the why. Because how many people think that if you know the meaning of something, you can define it. But if you know the why of something, you can solve the problem if this is a problem. So, in the beginning, the Telefonica College like to explain me the way of the cybersecurity using an example. And I think this is a good idea, and I will do the same. I think every people here know the Forrest Gump film, and this is the scene. Oops, sorry. Okay. Oh. Vaya. Okay. No problem. So many people here know this sense. It's the sense that Forrest Gump have seats, a dog seats, and this is the why of the cybersecurity, because the seats happen, and like the seat happen, the cybersecurity problem happens. The reality is the threats happens, the data leaks happens, the security hole happens, and the important thing is that you know what happened and you understand the why, you can solve it. Well, we know why the cybersecurity exists, and now we want what is the cybersecurity. Okay. I think in the world, every company has its own definition of cybersecurity, everyone. And this is our own definition of cybersecurity. Cybersecurity is just a collection tool. It's just capabilities to detect, to prevent all the security holes or the security threats. So, better than explain what a security hole is, or better than explain what a threat is, I think it's best for us to look at a sample. I am out of the system. Okay. And I will try to do the sample. I have the sample in my computer, but here.
Excuse me.
is the right? Where is the mouse? Okay. Okay. How many people here know Sodan? Sodan. The same people know cybersecurity. Okay. Okay. How many people know this? Know Sodan? Okay. Sodan, somebody named as Dark Google or Black Google. The reality is Sodan indexes, not index the information of the web page, index the content of or the server of IP. For example, we can do this kind of queries. Oops. Sorry. Okay. With this search, we looking for all the servers that contain in the URL the words Opcenter. And for example, we see that in this server, I have a Cassandra system, and in this Cassandra exists a key space with the key space name Solar, and other one with the Opcenter name. This means in this server there is a Cassandra and there is Opcenter, and if we are lucky and the people don't change the default configuration, the port of Opcenter is 8888. And if we are lucky, we can access to his Opcenter. So we'll try. Okay. Oh, not lucky. Okay, no problem. If we look for one cluster with the name, for example, test cluster, okay, there is one. Maybe these people don't change the default configuration. And, okay. Let's go. Okay. We are lucky. And now we are into the system. These systems are in Dortmund. And I don't know, the name of the cluster is test cluster. They have only one node. And if we want, we can, I don't know, see the data, explore, restart the cluster. This is only an example. More. If we want other search, for example, we are in San Francisco. So if we try to search the city, for example, San Francisco, okay. Oh. No. Okay. These people is not registered in the web page of Sodan and is limited the search by the time. But okay, don't worry. This is just a little example. The people can do it with your information. So. Let's go to the presentation. Oh. Okay. Okay. This is just only an example of the people can do it with this information. Just you have your system in internet and everyone can enter in your system and kill your cluster, or worse. This is a lot of example about vulnerability in internet and the fault configuration. This is a lot of information about vulnerability that the people can use to access your system. But all start to extract information. And the first protection must be protect our information. These are only two examples of the sample information that a hacker analyzes to detect the vulnerability and to exploit it. The important things is the threat are simple or are complex, but the beginning of a data leaks, the beginning of a threat or another attacks is just a little mix of configuration, a weakness, a default password, something else that other person can use. I think the most important to understand the cybersecurity is the cybersecurity has two sides, the motivations and the threats. The normal motivations are activism, cybercrime, cyber warfare, and cyber espionage. But what is the main important threat? What is the most important threat in this list? The negation server, SQL injection, defacement, account hacking? No. The most important threat is the unknown. Because if you don't know anything about something, you don't know protect with them. Because you can measure this type of attack. You don't know them. And you can do anything if you don't what has happened. You only can discover, detect them, and in this moment try to resolve the problem. So time to fail. In Telefonica, the people that detect this kind of threats are named as Goodbuster, because they have to detect something that they don't know anything about. The only things they know is the results, when they have detected something. And in Telefonica, analysts works all the information that they have and process with the intelligence to anticipate, to prepare use to the threats. To do this, they need to get a lot of information from a lot of sources, from different types, and we need to extract any alerts, any reports in real time to inform the customer. They want to change the corrective tools to the preventive tools. Alarms, report, trends, etc. is important here. They need to be alerts all the time and analyze all the strange behaviors to extract alerts. So they need a Skynet. But a scanner is just a machine in a film. So they ask us.
Well, as we have seen, the biggest problems for cybersecurity are the unknown threats. So you need applications that are smarter. So you need something like Skynet, and then they ask us to build something really very innovative and very smart. And here is where Cassandra and Spark and the big data technology joins. So this is where Telefonica met Stratio, and we combine efforts. You can see here the blue part is the one that we built. So it was something about cloud, NoSQL, and big data technology. And we go to the real important part of the presentation, which is the Cassandra and Spark processing part. We had 3 phases. Just to simplify and to go to the Cassandra part, there were an ingestion phase. We were using Kafka, and you have seen something about Kafka in the previous presentation. Then we had to make some transformation to the data, but also to analyze the data that was entering the system, and that was real-time processing. So we were using Storm. And for the batch and analytics, we were using Spark. And here is where the intelligence, where Skynet was starting to be built. Because you really need to build very smart applications to be able to detect the unknown. This is the part and the topology and that we follow. Here you can see the Cassandra nodes, and then Spark is working with these nodes. We were accessing Cassandra in two ways. The first way was directly going to Cassandra to write, to read, and to use the API. And the other one was to use Spark to transform the data that was in Cassandra or to apply any machine learning algorithms or more heavy processing. So with this combination, really we were able to build an impressive application, really good to detect the unknown. This is why we use Cassandra. Well, I think everybody here knows Cassandra, and we all love Cassandra and the way it is handling the data, but the read-write performance was one of the fault tolerance and Cassandra query language, and really it fulfilled all our expectations. Here we can see some of the tables, so Antonio can explain us why and what was the structure of the data.
Okay, so they need to make two kind of queries in the batch phase. One of them was direct queries to fuzz with the relationship between entities. For example, IP and domain. And these queries should be very fast. And the other is special and custom queries for the analyst. For the first kind of queries, we use Cassandra directly. And for the others, we use Spark with Cassandra. Using the data modeler of Cassandra, we have all the direct queries that the Telefonica wanted and need. This kind of queries consisted in relationship between entities. For example, between IPs and domains. A normal queries was an IP to extract all the to extract for one domain. And when we have a IP list to have information of these IPs, you can see in this the table of, we can use. Some little example because the information is a little restricted. And in this example, we have an example of tables in the cluster. The integration with a storm is managed to normalize the data and save the information in the correct site. We have a main table for the IPs, and in this table, we have the IPs in the primary key. So this is our primary key. This is the raw information. We save the raw information and the process information. And in this row, we need to split for the time, because one IP can have several domains in different moments, and we don't want update information. For this reason, the data modeler of Cassandra is perfect for this use case. And the queries can be searched with IP or set with a domain. For this, we do a table view. We have a table view with the domain in the primary key and a list of IPs, because the normal query of this table is with a domain, extract all the IPs in this domain. And when we have the IPs, we extract all the information of these IPs in the raw data. For this reason, Cassandra Data Modeler was perfect for this use case, and the same for the domain and the others and the other source.
So at the end, I think important parts is what we have learned and what can we advise to others to use? Big data has like two separate worlds. One is the big data processing with the Hadoop platforms and Spark and this part. And the other one were the NoSQL databases. And they were not working together. We saw a perfect combination, and really it is the best of these both worlds. But there were a big risk. When you are adding components to a stack, it could grow really very complex project at the end. And this is that we are finding now in the market. Different technologies, and you are just adding new technologies to the stack, and at the end you are using Storm, Scoop, Hadoop, Impala, Kafka, and it is really messy. So one of our first advice is to simplify. We choose Spark because with Spark you can do everything. You have the batch, you have the interactive, you have the streaming real-time data analysis, and also the machine learning. So just one stack to rule them all. So first advice, be rational, not only emotional. Maybe you really like the technology, but don't get into the error to add more and more different technologies and to build something very complex. Why? Well, in big data, everybody started working with Hadoop, so we have something like an emotional connection with Hadoop, but we don't use Hadoop processing, because really if you combine Spark with Hadoop, at the end you are making these messy systems with a lot of products, and later you have to deploy, to manage, to develop. So we all love Hadoop, but if you are using Spark, you don't need it for processing. At the end, this is our advice. Don't go for hybrid platforms. Don't use Hadoop plus any other 20 components. Go for a pure Spark platform with Cassandra or other components. Why? Because here we are talking about a real project, not a proof of concept. And a real project for a big company with really huge quantities of data, you will have to deploy the system, to manage the system, to develop, to maintain. And this is really complex. It is so complex that if you have too many components, it will be crazy. For example, in some projects we had a Storm and we had to replace a Storm because the Storm topologies were so complex to deploy that it was just not possible. So this is that at the end we are using Cassandra and Spark, Kafka, and not more than 7 components. The other thing that we have learned that the combination is really good. And we really think that combination is the future of big data. Really a lot of several different types of combinations. Here you can see Cassandra, okay, Mongo, we'll delete it later. Elastic, HDFS, HBase, and more combinations. Why? Because the persistence containers that you can find in big data are very specialized. So if you want raw data, HDFS is all right, and you can even compress the data in HDFS and have huge quantities of data compressed there in HDFS, is all right. But if you want to process it or something more valuable, then a NoSQL database is really good. If you want to make a test search, well, Elasticsearch or Lucene is the proper persistence container. So we really think that the future of big data is combination. Here you can see an example that we tried in this project was to combine, but also to simplify things. So that we were doing at the end was to be able to make a query, a SQL, a very normal one, combining test search plus a normal query. This is one type of combinations, of course. And also, we combine Lucene with Cassandra to make a more advanced secondary indexes So with this, we are able to speed up Cassandra in some queries up to 50 times faster. And so combination is really very, very powerful. Not only combination about containers, persistence containers, also combination about processing. Here, that we combined into the system was streaming. The beginning of big data was batch, and you were processing data for hours, maybe days, and that was the beginning. But more and more, the customers, the clients are demanding real-time data analysis and combine store and real-time data entering in the system. So the streaming engines are very, very important. So combine batch analytics with the Spark streaming analysis, and it is a very, very powerful combination. And here we combine even other thing. We are using Spark streaming with Kafka, but also with a complex event processing engine. And in this way, you can detect for fraud security or recommendations or matching data intelligence or anything. You can make a lot of different use cases with this. This is that we think is a part of the future combination, trying to use all the possible types of data. Stored data, it is pretty easy to use and analyze stored data in normal tables. The present is the data that is entering in the system. So it's real-time data streaming, and we create something called ephemeral tables. Why? Because you need something to be able to combine a normal table in a SQL sentence with a table that doesn't exist because the data is entering. So we are using their time windows to say, okay, store for 10 seconds all the data that is entering, and to make any SQL operation between the data that is entering with the data that I had stored. So no more Lambda architectures, no more complex technologies, just SQL, nothing else. And the future that we are building, we think part of the future is the machine learning and predictions and all this stuff, all this technology. So we think that we have to combine past, present, and future to combine the result of the machine learning algorithms and the data models in something called quantum tables. It's data that still doesn't exist. You have some probability for that data to occur in the future. So in a SQL sentence, you can combine the data store with the data that is entering and with the data that maybe in one day, 1 month, you will have. And we think this type of combination is also very powerful, and we are using it right now. So this was like our experience, combination, speed, future and machine learning. So thanks for paying attention, and if you have any question, please.